Every single day, Americans throw away enough glass bottles and jars to fill a 40-story building. That's over 13 million glass containers hitting landfills daily, where they'll remain virtually unchanged for over 1 million years. But here's what most people don't realize. Glass is infinitely recyclable without any loss in quality or purity. One recycled bottle can become a brand new bottle, then get recycled again and again, forever. So how exactly does this incredible transformation happen? How do millions of dirty, broken glass pieces get turned back into crystal clear bottles ready for your favorite beverages? Today we're breaking down the fascinating process behind one of the world's most advanced glass recycling operations, where over 800 tons of glass waste gets completely reborn every single day. Make sure to subscribe as we dive deep into this remarkable journey of regeneration. The magic begins long before any glass reaches the recycling facility. Collection trucks rumble through neighborhoods across the country, gathering millions of bottles and jars from curbside bins. These aren't just random pieces of glass. Each container carries a story. Wine bottles from celebrations, beer bottles from weekend gatherings, jam jars that once held homemade preserves, and soda bottles from family dinners, all destined for an incredible second life. When these collection trucks arrive at the recycling facility, they're carrying far more than just glass. Mixed in with the bottles are metal caps, plastic labels, ceramic pieces, stones, and countless other contaminants that somehow made their way into recycling bins. The first challenge? Getting all that glass safely unloaded without creating a dangerous mess of sharp fragments everywhere. Massive hydraulic systems tilt each truck bed at precisely controlled angles, allowing tons of mixed recyclables to cascade onto specially designed conveyor belts. These aren't ordinary conveyor systems. They're engineered with reinforced steel mesh surfaces that can handle the constant impact of heavy glass containers dropping from heights of up to 12 feet. The sound is absolutely thunderous, like a never-ending percussion symphony of clinking, crashing, and grinding. But this controlled chaos serves a crucial purpose. As the glass tumbles and bounces along these initial conveyor belts, the first separation begins naturally. Lighter materials like plastic bottles and aluminum cans tend to bounce and separate from the heavier glass, which settles toward the bottom of the moving stream. It's physics in action, using density and weight to start organizing this massive mess of materials. The conveyor system moves this mixed stream at a carefully calculated speed of exactly 4.7 feet per second. Too fast, and glass bottles would shatter unnecessarily, creating more small fragments that are harder to process later. Too slow, and the facility couldn't handle the enormous daily volume. Engineers spent years perfecting this exact speed to maximize efficiency while minimizing waste. As millions of containers flow down these initial conveyors, trained workers positioned at strategic points begin the first round of manual sorting. Their eyes scan the moving river of recyclables at lightning speed, plucking out obvious contaminants that could damage downstream equipment. A ceramic coffee mug here, a chunk of concrete there, maybe a stray piece of metal that somehow escaped earlier sorting processes. These workers can identify and remove up to 300 contaminated items per hour, their hands moving in practiced motions, honed by months of experience. They wear specialized cut-resistant gloves rated to withstand sharp glass edges because even the smallest oversight could result in serious injury. Safety protocols require glove changes every 2 hours to maintain maximum protection. The sorted glass now moves toward the facility's first major technological marvel, an advanced optical sorting system that can identify different types of glass faster than the human eye can even register. High-powered LED lights illuminate the moving stream from multiple angles, while sophisticated cameras capture over 15,000 images per second. These aren't regular cameras. They're hyperspectral imaging systems that can detect the molecular signature of different glass compositions. Clear glass reflects light differently than brown glass. Green glass has its own unique spectral fingerprint. Even blue and amber glass, which might look similar to human eyes, show up as completely different materials to these advanced sensors. The system can distinguish between more than 47 different types of glass and glass-like materials, separating true recyclable glass from problematic look-alikes like ceramics, light bulbs, and heat-resistant glass that would contaminate the recycling process. When the optical system identifies non-recyclable materials, precisely timed air jets fire with incredible accuracy, blasting unwanted items off the main conveyor and onto separate collection belts. These air jets operate at pressures of up to 90 pounds per square inch and can fire in bursts as short as 10 milliseconds. The precision is absolutely mind-blowing. They can target individual bottle caps while leaving the glass bottles completely undisturbed. Now we're getting somewhere. The remaining stream consists almost entirely of recyclable glass, but it's still a mixture of different colors that need to be separated. This is where the real technical wizardry begins. Because the quality of recycled glass depends entirely on keeping different colors from mixing together. The color separation process is absolutely critical because even tiny amounts of mixed colored glass can ruin entire batches of recycled material. Think about it. One small piece of brown glass mixed into clear glass will tint the entire batch, making it unsuitable for premium applications like high-end beverage bottles. The financial impact is enormous. A single contaminated batch can cost the facility up to $50,000 in lost revenue. Advanced color sorting machines use a combination of near-infrared spectroscopy and visible light analysis to achieve separation accuracy rates of 99.8%. These machines process over 12 tons of glass per hour, with individual glass pieces traveling past sensors at speeds exceeding 20 miles per hour. Each piece gets analyzed in less than 5 milliseconds before pneumatic ejectors precisely direct it to the correct color stream. The clear glass stream, which makes up about 70% of all recycled glass, flows toward one set of processing lines. Brown glass, representing roughly 15% of the total volume, heads to its dedicated pathway. Green glass, making up most of the remaining material, follows its own route. Even rare colors, like blue and amber, get their own specialized handling to maintain maximum value in the recycling market. But color separation is just the beginning. These glass pieces are still covered in labels, adhesive residue, metal caps, plastic rings, and countless other contaminants that must be completely removed before the glass can be melted down and reformed. This is where the intensive cleaning process begins, and it's far more complex than most people imagine. First, powerful industrial shredders break down the sorted glass into more manageable pieces. These aren't gentle machines. They use rotating steel hammers spinning at over 1,000 revolutions per minute to systematically crush glass containers into fragments roughly the size of marbles. The sound is deafening, like standing inside a thunderstorm made of breaking glass. Dust control systems immediately capture airborne particles to protect workers and prevent environmental contamination. The crushed glass, now called cullet, flows into massive washing systems that would make your dishwasher look like a toy. These industrial washers use heated water at temperatures reaching 160 degrees Fahrenheit, combined with specialized detergents designed specifically for glass cleaning. The washing process isn't gentle either. High-pressure jets blast the cullet from multiple directions while rotating drums tumble the glass pieces against each other, creating friction that scrubs away stubborn contaminants. Paper labels dissolve almost immediately in this heated wash, but plastic labels require much more aggressive treatment. Steam injection systems heat the water to near boiling temperatures, causing plastic labels to soften and separate from the glass surface. Powerful suction systems then extract these floating plastic pieces before they can recontaminate the cleaned glass. Adhesive residue presents its own unique challenge. Standard washing won't remove these sticky substances, so the facility employs caustic washing stages using sodium hydroxide solutions. This chemical treatment literally breaks down the molecular bonds in adhesives, allowing them to be completely washed away. The process requires precise pH monitoring to ensure effectiveness while preventing damage to the glass itself. Metal contamination gets removed through magnetic separation systems, positioned at multiple points throughout the cleaning process. Powerful electromagnets, some generating magnetic fields over 10,000 times stronger than Earth's natural magnetism, pull ferrous metals like steel bottle caps from the moving glass stream. Even tiny fragments of metal invisible to human eyes get captured, because any metal left in the glass would create defects in the final recycled bottles. For non-magnetic metals like aluminum, the facility uses eddy current separators. These ingenious devices create rapidly changing magnetic fields that induce electrical currents in aluminum pieces, causing them to literally jump away from the glass stream. It's like watching metal pieces perform acrobatic leaps as they get ejected into separate collection bins. The cleaned cullet then faces one final inspection before moving to the next major phase. Human quality control specialists examine samples from each batch under magnifying equipment, looking for any remaining contamination that automated systems might have missed. These inspectors can spot foreign materials as small as 2 millimeters in diameter, their trained eyes catching problems that could ruin thousands of pounds of recycled glass. Water used in the cleaning process doesn't get wasted either. The facility operates a closed-loop water treatment system that filters, purifies, and recycles 97% of all cleaning water. Contaminated water gets processed through settling tanks, filtration systems, and chemical treatment stages before being reused in the washing process. This environmental responsibility saves over 2 million gallons of fresh water every single month. Now comes the final preparation before the glass can be transformed back into new bottles. The cleaned cullet must be sized to exact specifications because glass furnaces require incredibly precise material consistency to operate efficiently. Industrial sizing screens shake and vibrate the cullet, separating it into different size categories. Pieces larger than 3/4 of an inch get sent back for additional crushing, while dust and particles smaller than 1/8 of an inch get collected separately for specialized applications. The properly sized, cleaned, and sorted glass cullet finally reaches temporary storage silos, each one capable of holding up to 200 tons of material. These aren't simple storage containers, they're climate-controlled environments that maintain optimal moisture levels and prevent contamination during storage. Automated conveyor systems move the cullet from these silos toward the heart of the entire operation, where the real magic of transformation begins. The massive glass furnace stands like a cathedral of industrial engineering, its refractory brick walls designed to withstand temperatures that would melt copper. This isn't just any furnace. It's a regenerative melting system capable of reaching internal temperatures of 2,900 degrees Fahrenheit, hot enough to turn solid glass cullet into flowing liquid in mere minutes. The engineering marvel burns natural gas at a rate of 12,000 cubic feet per hour, generating enough heat energy to power 300 average homes. Automated feeding systems precisely control the flow of cleaned cullet into the furnace. The process requires mathematical precision because the ratio of recycled glass to raw materials determines the quality and characteristics of the final product. Most bottle manufacturers use between 70 and 90% recycled cullet, mixing it with carefully measured quantities of silica sand, soda ash, and limestone to achieve the exact chemical composition needed for strong, clear glass. As the cullet enters the furnace, something absolutely incredible happens. The solid glass pieces begin melting from the outside in, creating a glowing river of molten glass that flows like thick honey. The temperature is so intense that the glass becomes completely homogeneous, with recycled material and raw ingredients blending into an identical molecular structure. This is the true magic of glass recycling. Old bottles literally becoming indistinguishable from brand new glass at the molecular level. The molten glass moves through carefully designed channels called forehearths, which maintain precise temperature control as the material flows toward forming equipment. These channels aren't straight pipes. They're engineered pathways that condition the glass, ensuring uniform temperature and consistency. Temperature variations of even 10 degrees could create stress points in finished bottles, leading to breakage during filling or shipping. Massive forming machines, each weighing over 50 tons, shape the molten glass into new bottles through a process called blow and blow forming. The operation happens with mechanical precision that's absolutely mesmerizing to watch. First, precisely timed gobs of molten glass, each weighing exactly the right amount for a specific bottle size, drop into individual forming molds. These gobs are heated to exactly 2,100 degrees Fahrenheit, the optimal temperature for shaping without creating internal stresses. The initial forming stage creates what's called a parison, essentially a thick-walled tube that will become the bottle's neck and basic shape. Compressed air, pressurized to exactly 40 pounds per square inch, inflates the parison from the inside, while the outer mold shapes the exterior. The timing is absolutely critical. The entire forming process takes exactly 12 seconds from molten glass to recognizable bottle shape. But these bottles are still glowing red hot and incredibly fragile. They immediately enter an annealing layer, a specialized oven that slowly reduces their temperature in a carefully controlled process. This isn't simple cooling. It's a precise temperature reduction schedule that takes exactly 40 minutes to complete. The bottles start at 1000 degrees Fahrenheit and cool to room temperature following a specific curve that prevents internal stress formation. Quality control during this process is absolutely relentless. Automated inspection systems check every single bottle for defects, using multiple technologies simultaneously. High-speed cameras capture over 1,000 images per second, analyzing each bottle for cracks, chips, dimensional variations, and wall thickness irregularities. Laser measurement systems check neck dimensions to tolerances of plus or minus 0.02 of an inch, ensuring perfect compatibility with caps and closures. Pressure testing equipment subjects random samples to internal pressures 3 times higher than they'll ever experience in normal use. Bottles that survive this testing prove the entire batch meets safety standards. Those that fail trigger immediate investigation of the manufacturing process to identify and correct any problems before more defective bottles get produced. The environmental impact of this entire process is remarkable when you consider the alternatives. Using recycled cullet instead of raw materials reduces energy consumption by 15% because recycled glass melts at lower temperatures than virgin materials. This single facility prevents over 60,000 tons of raw materials from being mined every year, while simultaneously diverting equivalent amounts of waste glass from landfills. Finished bottles flow from the production line onto packaging systems that prepare them for shipment to beverage companies, food processors, and other manufacturers. These aren't the same bottles that entered the recycling system weeks ago, but they're molecularly identical to bottles made entirely from raw materials. The circular economy in action, waste becoming valuable products without any compromise in quality or performance. The facility operates 24 hours per day, 7 days per week, processing over 800 tons of recycled glass daily. That translates to approximately 2.4 million individual bottles being recycled into new bottles every single day. In 1 year, this single facility prevents enough glass waste to fill a football stadium while producing enough new bottles to supply beverage companies across 6 states. And just like that, the incredible journey from broken waste glass to pristine new bottles reaches its completion. Every bottle that rolls off this production line represents a victory over waste, a triumph of engineering, and proof that sustainable manufacturing isn't just possible, it's profitable and practical. The next time you recycle a glass bottle, remember this amazing process and the remarkable technology that transforms your trash into treasure. What manufacturing process would you like us to explore next? Drop a comment below and let us know what you think. And don't forget to like, share, and subscribe to keep exploring more fascinating industrial journeys with us.